Alright, hi everyone. This time I want to introduce to you the workflow of RAG, Retrieval-Augmented Generation. This workflow is divided into three parts: data injection, chatting, which means actually chatting with the agent, and a re-evaluation process. First, let me explain what retrieval generation is. Simply put, it uses Take your reference documents and carefully break them down into smaller, more manageable chunks using a method called LOLs. After this, store these chunks in the vector database. Later, when a question is asked, the question itself is also converted into a vector. Then, within the vector database, the system searches for the most relevant corresponding chunks or fragments. These retrieved fragments are then used to help the large language model, or LLM, answer the question more accurately and effectively. The diagram looks roughly like this. You have some reference documents, then you embed them and store them. When a question comes in, there are two paths. The first is to embed the question, then search the database for the corresponding documents or contexts, that is, parts of the documents. Then you take that part of the document along with the question and feed them both into an LLM, like LOL. Then this LLM uses the corresponding reference information to answer the question. Basically, that's how it works. Alright, so let me try the first part. First, I have a Google Drive folder, and in that folder I can put some reference documents. Then, these documents will be inserted into an iPhone's Victor base, so that's how it works. I'll just put them here for now. Because of time constraints, I've already prepared some files. I have this leaflet, this product, and the leaflet upload. So, what's next? I'll go through this workflow and you can take a look at it now. This is another record in the system. After I finish this workflow, once I go out, you should be able to see it. It should be there. There are more records after refreshing. Hold on a second. Yeah, that's right. There are 93 records now. So, what next? I'll upload one more. Hold on a sec. So like this. Let's run it one more time. Alright, it's done now. Can we take a look? So it'll become 289 records, right? Okay, that's good. Some data has been entered. We can do a simple test. In this workflow, I'll use Telegram as an interface, but you can use other interfaces too. If you connect it like this, you can input voice, and you can also input text. The text input is at the bottom, and the voice input is at the top. So let's see what happens next. In the middle, it'll go through something called Guardrail. Guardrail is something we had issues with in our previous company as well. We ran into this problem before, right? That's it. So the company's policy, right, they don't want, when chatting with the LLM or the AI to involve any sensitive information. For example, PII. Like if a customer gives their policy number or phone number to the LLM, then it gets stored in the model's data. So this is the issue. There's a risk, so you can't just send customer information over like that. That's why there's Guardrail. This Guardrail is really useful, so it filters and sanitizes the text, meaning it screens out certain content before sending it over to the model, like the LOL. So I set up two filters, one for policy numbers and one for Hong Kong, China phone numbers. I want to give it a try, so the filter and sanitization happen first before sending it over to the... So the model handles it over there, and the model, So it pulls from the Victor database, right? Based on that query, it then fetches the corresponding prompt, checks it again, and only then will there be a response. After responding, it will reply back to Telegram. But let me just try a simple hello to test it out, and I'll ask it using voice first. Hello there. So I greeted it and just tried it out. I can see the response here, and then it asks, is there any insurance product I can help you with? So let me ask what products it can recommend. Could you please tell me what products you can introduce to me? So just to clarify, did he simply introduce these products, or was there any additional explanation or context provided when he presented them? Well, that's about it for now. Then, as I've mentioned before, I can go ahead and demonstrate that Guardrail, as I say, is exactly what I have described it to be. Oh my god.
Hello, 61,234. 1,231,234. That's it. Please help me check. Teach me how.
London. So you can see it went to the line below, because it immediately recognized that, hey, this doesn't involve any privacy approval process, so that's already gone. First, it won't answer directly. Second, we can see that when Guardrail receives it, there's a phone number, but when it outputs, it's already been masked, and it just shows Hong Kong, China. So the phone number, right, so before it's sent to the LLM, it's already been filtered. This one has been successfully screened out. Okay, so that's basically the end of the demonstration here. Also, I've added a conversation log at the back, so we can take a look at the previous one. Conversation. So, looking back at the Envier, here the questions, answers, and who asked them have all been logged. As mentioned earlier, the phone number has already been marked, so this avoids any issues with PII showing up. Alright then. Basically, that's it for the Q&A part. Next, we'll move on to the evaluation section. So in n8n, there's actually an evaluation feature. You can use it to evaluate. Basically, you give it a set of questions and answers, and it will judge how accurate the answers generated by January are. I've already done one before. I ran several tests using, for example, ChatGPT 4.1 Mini, ChatGPT 5.1, Gemini 1.5, and also the recently popular Minimax M2 and KidMe K2 Thinking. These last two are both domestic, right? There's some models from China, and they're also open source, which is why a lot of people are talking about them. In terms of performance, their capabilities are on par with those foreign closed-source models, so that's why a lot of people have been talking about them lately. So I decided to do a comparison among all these models, and here are the results. First, let's look at their accuracy. At the beginning, these three here are... ChatGPT's 4.1 million version only scored in the 40s, and on average, each token is just over 100. Then I tried the newly released ChatGPT 5.1 a few days ago and tested it again. The first two runs actually scored even lower, with only about 30-something% accuracy, just 3-point-something, 30-something%. So then what about the third time? There was also a rate limit. Maybe I used it too much. Now there's even an error due to the restriction. Also, let me explain how I calculated that accuracy. Actually, when I use the LLM to grade, it should be in the evaluation section later on. So when I grade, the accuracy is actually based on correctness, that is, how accurate it is, and also on how complete it is, the completeness. Then an accuracy score is calculated from that. The formula should be there. Let me take a look first. It should be here, right? Yeah, that's it. So this is the accuracy, which equals correctness times 0.5 plus completeness times 0.5. Yeah, so that's the answer. So, like this? Let's go back to the previous point. Yeah, so these three all use the latest CheckPD, CheckGPT 5.1, and then the next two use Gemini 2.1.5, but the results aren't particularly high either. They're all averaging around 4 points, which is about the same as before with CheckGPT 4.1 Mini. Then I tried two other domestic open source models. So they're all pretty close, all around 40-something points. And what about this one? As for KidMe K2, it's even lower, only in the 30s. So actually, most of them are just in the 30s to 40s, not particularly high. But you can see the difference here. These two open source models, because they're thinking models, they use a lot more tokens, over 700 and over 1,000. In comparison, Open1 Mini only uses a bit over 100 tokens, and 5.1 uses around 300 or 400, and so on for the others. Gemini Pro also uses around 300 to 400 tokens, but these two models in particular use a lot more tokens, so they're much more expensive, and they also take a lot longer. In the end, the machine took over 70,000 seconds to do the calculations. Then I started thinking, why is it like this? Actually, it should be. The information I provided to it just wasn't enough. Those two documents weren't sufficient to answer the questions I was asking it to answer, but actually, those Q&A questions were just... Let me take a look here. So in this case, I use this queue, and everyone is using this n8n date table. But honestly, this data table still has a lot of room for improvement, even though it's pretty recent, maybe just released last month, but still. Honestly, it's not particularly user-friendly. You can't export it, you can't copy and paste, and if the text is too long, you can't see it all. There's no option to filter or scroll down like in Excel. Maybe in the future, as it improves quickly, it'll be able to handle a lot more tasks. But one advantage is that it's NA native, so it's fast. That's why, for most things that need to be processed quickly, I put them in this data table. So for example, this one, hey. For the plan, there are insurance plans, and there are age restrictions for both the insured and the policyholder, so you have to be over 18. If you're under 18, you need parental or guardian consent first. That's basically how it works. I've made 3 in Chinese and 3 in English. Yeah, that's right. And then, well... So after they've reviewed this stuff, they can check the results. For example, let's say I got a higher score, like this one, 45 points. Then you can take a closer look, and you'll notice, hey, actually, some of the answers are correct. This one got 90 points, this policyholder. The definition of the insured person, they answered that really well. And same here. Also, some of the terms and conditions, too. When it comes to concrete facts, they can get those right, but when it requires inference, their answers are really poor. For example, like this one. When it comes to deducing the answer, they just can't do it. Some even scored 0, like this one here, 0 points. Couldn't answer at all. And the rest of these are also pretty bad. So actually, it's because the information is insufficient. So in the world of AI, the more data it has, the better it performs. It gets more accurate. On the other hand, which model you use, whether it's a thinking model or a simple model, the results are actually pretty similar. So for my final test, I gave it one more document, like this. I uploaded another document, an FAQ, basically giving it the answers from earlier to see what would happen. Let me open up the FAQ. That's it. I gave it all the answers from earlier, so now it knows what the standard answers are. Then I ran the evaluation again, and of course, the results were much better, 89.40. It's still not a perfect score, but it's much higher than before. There were still a few lower scores, like 70, but some were spot on. Some even got a perfect score of 100. So, you see, the data you feed into the LLM for it to learn from is extremely important. From my past experience, when building a chatbot like this, it's best to use historical data. For example, the conversations the CS team had with customers in the past. Maybe you've collected several years' worth of dialogues. You can extract suitable Q&A pairs from those conversations and then use them to train the chatbot. The results will be much better this way. Compared to just giving it a document to process, the quality of its answers will be significantly improved. That's all for today's sharing. If you have anything to add or want to discuss something, feel free to leave a comment below. Thank you.